And then in terms of the end cooling, Chris Anthony mentioned that for the larger capacity cells, there was a plan to use formats of cells that are the same diameter but longer in length to give higher capacity. Um, is that going to be a problem for the end cooling? Because now you have a longer cell and it has to, the heat has to travel a longer distance. Has that been tested, or is it
We
too
have not
early to
tested it
talk
yet.
about that kind of stuff?
Yeah, it is too early because our focus right now is not on the higher capacity pack.
Mhm.
But back to the overall intent of the vehicle, regardless of the size of the battery, the vehicle's still going to have roughly the same power draw when you're driving it down the road. So
Mhm.
you don't really need to remove any more heat from the big cells. You just need to do it for longer. I guess that's misspeaking in technical terms. You do need to remove more, but not at a higher rate.
Mhm.
So the batteries might last for, let's say, I don't know, 8 hours of driving. So you'll be removing heat for 8 hours versus four if we double the capacity of the pack, but you won't be removing it at a higher rate.
Okay.
And during driving, the heat removal isn't that critical anyway because the draw is relatively low, so there's negligible heating.
Right. The biggest heating stress would be during DC fast charging, correct?
Correct. Yeah.
Okay. And how is that going to be tested for? Like, are you going to test higher and higher rates and see at which point the pack fails, or how's that done? I'm not familiar with the process of testing for DC fast charging.
Well, you just described it.
Okay.
Yeah, that's exactly what we'll do. So we've already tested the individual modules
Uh,
at a 1C and a slightly over 1C, about a 1.5C rate.
mhm.
And that was done without active cooling. The batteries going into these vehicles will be tested with active cooling. So we'll be able to test them upwards of 2C rate, which is beyond where we plan to charge anyway.
Uh-huh. A 2C rate at of a 44 kilowatt hour pack, is that like, are we talking 90 kilowatts? Is that
Yeah,
right?
for those unfamiliar with the C rate nomenclature, um, a 1C rate represents charging a battery from empty to full in precisely one hour, or discharging it from full to empty. So if you have a little 21700 cell, it has about 5 amp hours of capacity. So if you were to run that thing at 5 amps, either charging it or discharging it, you're running it at 1C. And if you charge it at 10 amps, then you'd be charging it at 2C.
Hmm.
Common for most devices that we're familiar with, like handheld drills and things of that nature, might be anywhere between C over 4 or 1C for household use items. And a cell phone, I don't know what those charge at, probably close to C over 2. But for vehicles, we want to push them harder because we'll be able to spend less time at the charging station. And generally, if you can get away with about a 30 or 40 minute empty to full cycle, that'll satisfy most applications.
Hmm.
Would
Hmm.
be just over 1C.
Okay. All right.
Challenges though, if you go too fast, you do get too much heating, and it also degrades the battery more rapidly.
Right. And having a smaller battery pack allows for 1C charging at a less power draw, right? Because like we have these 250 watt, 250 kilowatt chargers. And then the early DC fast charging was 50 kilowatts, right?
Yep,
And that would be 1C. 50 kilowatts would be 1C for the Aptera.
right.
Okay. All
That's
right.
correct.
Okay. Um, so is the battery pack design now finalized? Are we like 100% finalized and we're just now building and testing, or is it still we still haven't nailed it down yet?
Well, it's as finalized as any good design can be until you build the first prototypes with the production intent tooling.
Hmm.
So we've built a number of modules and systems with prototype tooling,
Hmm.
many of the parts being 3D printed, for example, or cast instead of molded.
Uh-huh.
But the PI builds that are underway now, those will be built with production intent tooling. So
Mhm.
the proper aluminum extrusions will be produced. They'll be welded as intended for the production vehicles. All of the materials will be the same as the production vehicle intent, which will then give us an opportunity to test the actual design versus testing some surrogate.
So is the production the battery packs that we saw in the most recent update, are those based on a production intent tooling or are those prototype tooling?
Those were prototype.
Mhm.
uh, the ones that'll go into, so that one that you saw was the aluminum frame was built from rectangular sections that were bolted together and then welded. So it was very much a prototype frame,
Mhm.
um, and it was built with modules, though they matched the production shape and material. They were not built on the production like for example, the bus bars or the current collectors, I bent those by hand with a 3D printed fixture.
Mhm.
The ones that are built on the production tooling will be from a progressive stamping system,
Okay.
and the injection molding tools will be actual injection molding instead of 3D printed
Okay.
in that case.
So the production intent battery, what do I call it? The battery tray, that thing that was bolted from rectangular things. How will that be built? Will it be forged or
Yep,
stamped
it's
or
extruded aluminum. So
okay.
the
What is that?
frame
I'm not sure
itself.
what that is.
Well, if you've ever seen like aluminum square tubing, for example,
Okay.
or actually maybe a more readily accessible example is a screen door frame or a
Okay.
screen window frame at your house. It's not solid aluminum. It's a very thin wall aluminum shape, and the shape can be relatively complex, like that of a screen door frame or a sliding door frame, for example. Um, and what that allows you to do is create a shape that has a lot of detail in it. It can have very specific external dimensions that will interface with the rest of the vehicle, will give the strength characteristics that you're looking for in any particular section shape, but then have the inside be largely hollow. So it reduces the weight, which of course is important for efficiency. So these are made by squeezing hot aluminum through very small holes in
Okay.
what are called dies. And those dies are what determine the shape of the extrusion.
I see. Okay. All
So
right.
the frame will be made out of that material, which is then welded together. And stamped aluminum, heat sink or cooling plates, stamped aluminum covers.
Okay. When are so the battery modules and that the prototype battery tray, is that what's going into the PI, the first drivable PI vehicle? Or
Yes.
okay. When should we expect like production intent tooling battery packs and battery trays? Is there a timeline for that?
I think we're looking at about 60 or 70 days from this point.
Oh, okay. All right. And so I in the latest video you talked about vibration testing.
Yeah.
What other testing are you guys thinking is planned for the battery packs?
Well, on a pack level, we'll do similar testing, shaking it around, shock, and so forth.
Mhm.
There are various electrical tests to confirm that electrical isolation is up to snuff. The high power cycling of the battery pack will be done in conjunction with cooling
Mhm.
under hot conditions, heating under cold conditions to confirm that the thermal management system can keep the battery under ideal operating conditions.
Mhm.
And then, of course, road testing, um, actual real world driving.
And how long does you think this testing takes in general? Like, does it take 2 months, 6 months, 9 months?
Uh, let's carve out the road testing and
Okay,
not address that because that can take, you we'll be learning for years about the batteries in the real world,
I
but
see.
the lab type testing, I would think it's probably a few months of testing.
Okay.
Environmental testing can take a fair bit of time to set up. Um, Building environmental chambers to put a whole vehicle in is certainly more involved than just an oven to put a battery in. So those kinds of things could push it out multiple months, I imagine.
Okay. Now you said that when the batteries are you've gotten with pat without any cooling, you can get 1C charging. You've tested that on the modules, and you figure that with active cooling, you could easily get 2C charging. Does that mean that Aptera is planning on allowing for like 100 kilowatt DC fast charging? Or is 50
I,
kilowatts still the design parameter that we're shooting for?
yeah, I'm not sure I'm prepared to answer that.
Okay.
Not because I'm avoiding sharing any information, but
Mm,
I'd just be more comfortable if we've had an opportunity to test it first.
got it. Got it.
But I don't think that a 2C charge, I think it's worth realizing that you really can't charge from empty to full at 2C. It's
Uh-huh.
just a convenient term that allows you to talk in sort of a unitless number that can apply to from one battery to the next.
Uh-huh.
The reality is when you charge at that rate, the terminal voltage of the cell itself gets rather elevated as you go past 50% or 60% of state of charge. So then you really have to start tapering off the charge rate as you approach the top of charge. So if you pulled up to a fast charge station with a completely empty battery and you're charging it at a 2C rate, you're probably only going to be doing 2C for 15 minutes or 20 minutes.
Right. Kind of in the middle of
And
the battery pack, right?
yeah,
Yeah.
yeah, or mid low end.
Yeah.
Um, so it's not even like you have to pull a tremendous amount of heat away from the thing for a whole half hour. It doesn't last that long.
Right.
But there are a lot of variables in there that we really need to test before we can make any firm commitment about what it's capable of.